mentioned, today we are going to focus on the machine learning, right? So we have already covered various prerequisites which are required for the machine learning implementation, which includes understanding of the Python programming. Followed by that, we have seen some libraries in Python which are useful for data analysis and data manipulation, which includes NumPy and Pandas, right? Today, we are going to focus on what is machine learning. Now, as far as machine learning is concerned, you cannot consider machine learning in a alone, right? Because there is a lot of overlapping between the data science and machine learning. So in the introductory part of today's session, for the first half hour, I'm going to cover some theoretical aspect of the machine learning along with the data science. What is data science? What are the different types of data types that are used in data science? How it is related to machine learning? What is machine learning? It's different types, and followed by that, so I will say intro to ML and data science. That is what I'm going to discuss in the first section, and how they are related. To show one diagram where you will come to know that how these two things are having lots of overlapping. And once this is done, we will focus on a linear regression. So that is one of the important machine learning model. So we will see the theoretical aspect of it, the math behind it, followed by we will also see its practical implementation using Python programming. So this is the agenda for today's session. So without further ado, let's start with the introduction to machine learning and data science. I hope my screen is visible to all of you.
Yes, sir, it's visible. Go ahead.
Yeah, okay, thank you. So what is data science? Now, instead of giving you formal, boring definition, let me start with one example. Let's say you own a factory, okay, any manufacturing factory, and then obviously for that what you will need is a raw material and some employees, right? And thereby you will produce some goods at the end of the day, or maybe it may take few weeks to produce that particular amount of goods. And obviously after that you will need some logistic arrangement to send that goods to the market. So this is the complete business scenario, business process. Now I want to discuss here two different scenarios. Scenario number one, let's say that, let's say at the end of each month, or maybe at the end of each quarter, you are earning, let's say 2 million rupees, right, through this business. So let's say for a particular month, or maybe for a particular quarter, there was a huge requirement in the market for your products. But unfortunately, since you have a limited raw material, limited human resource, you were not able to match the market demands, right? So in this way, you could have earned extra income, but now you are still earning the 2 million rupees. So in a way, you are having losses, right? You could have expand your business, but that is not possible in this case. Let's consider the scenario number two, where you have procured the large amount of raw material. You have also hired more number of employees, thereby doubling your production capacity. But for that particular quarter, or maybe for that year, there was not that much requirement in the market for your products. So in this case, what will happen? Maybe you are expecting the revenue of 4 million rupees, but now you are having losses. Got it? So in either cases, you are having losses. Now, how to reduce this loss? How to increase your revenue? Well, for that, what you can do is, here comes the data science and machine learning into picture. So you will hire a team of data scientists, and first they will data scientist and machine learning engineer. They will ask you for some data. Now, let's say you have some software uh, in which you are storing all the sales transaction, right? So maybe you will have to give them that sales data, or maybe you can hire some external agency which will do survey in the market at what kind of features they are looking forward for in your product categories. Or maybe if your product is sensitive to some extreme weather condition, right? So in that case, maybe you will have to purchase some weather data from third party vendor, right? So there could be various sources of the data collection. That is what I want to point out here. Fine. Once the data is collected, you will perform some data analysis and data cleaning. Real life data is quite messy. There might be a lot of data, there might be a lot of indiscrepancies in that data. So through some scientific methods, you will perform some data analysis and data cleaning. Once that is done, you will feed that clean data to the machine learning model, and you will be training your machine learning model on this data. I'm going to explain what is machine learning model and what do you mean by training in a while. But let me just give you a view of, let me just give you a high level picture of what is this data science and machine learning is all about. And let's say this machine learning model is designed in a such a way to predict the sales. Got it? Now, since you have such kind of prediction system at your hand, you can now accordingly procure appropriate amount of raw material, employ correct number of employees, thereby producing the exact number, exact amount of product, which is the requirement of the market. So in this case, now all these predictions will not be 100% correct, but even if you are able to have achieve, few percent of accuracy, in that case you can see that you are able to streamline your business process, right? So in this case, you can see that your income has been increased from the 2 million to 3 million rupees, right? So that is the power of data science and machine learning. So in a nutshell, data science is all about study of the data. And this study involves various operations such as extracting the data from the source. I have already mentioned what could be the possible sources of the data, such as the database. I've shown you the sales data, right? So sales data is present in the application which resides in the inside a database, right? There could be surveys done to collect the data from the clients, or you can also purchase the data from some third party vendors which provides example of weather data, right? So once you have extracted the data, next step is to analyze, visualize it, manipulate or managing it. And after doing all these things, why we are performing all these operations? In order to create insights out of it. And what is the use of these insights? Using these insights, businessmen or big enterprises will take data-driven decision in order to maximize their revenue or in order to streamline their whole business process. I hope you have got the definition of data science. Now, as far as machine learning models are concerned, they process types of structured data, another one is unstructured data. Now, what is structured data? Any data that can be arranged in the form of rows and columns or in a tabular form is basically a structured data. So table inside your databases or Excel sheet data, right? So all these are examples of structured data where you have rows and columns, right? Data examples include email, text data, social media likes and post data, images, audio, video. So all these are examples of unstructured data. Fine. So that was all about the data science part. Now let's focus on the machine learning part. Now why I have first introduced you to the data science, because going ahead you will find out that this ML, this machine learning and data science have a lot of overlappings, right? So I thought of discussing the data science in the first section. Now let's focus on the machine learning part. Now, what is machine learning? Before that, I would like to talk about something called as learning. I have a question for you. What is this symbol on the screen? I know most of you must be saying that what kind of ridiculous question is this, right? This is a digit 2, but how do you recognize it? Because in your nursery school, you might have drawn this particular symbol many times, right? And while drawing it, you learn the pattern in this symbol, that there is a curve shape like this, followed by a horizontal line like this. Got it? So once you understand the pattern, you remember this particular symbol, right? And doesn't matter if 2 is presented to you in a different size or with a different style, you will be still able to recognize that particular symbol. Not only that, you can also distinguish between the digit 2 and non 2 digits, right? The digits which are not number 2. So scientists come up with an idea. What if we could develop similar learning capabilities within a machine? When I'm saying machine, I'm talking about a computer machine. So the thought of creating similar capabilities of learning within a machine. So what machine will do is that it will we will feed the data to the machine, and then machine on its own will learn the complex patterns within the data without any need for explicit programming. It will remember those patterns, and next time whenever a new data is presented to it, it will able to recognize the pattern, or it will be in a position to make the predictions. So how this can be done? Well, it is done with the help of something called as machine learning models, right? So what are these models? These models are nothing but mathematical models. Now, whenever I say mathematical models, it means that these are nothing but some mathematical equations which basically understand the underlying structure in the system. Now, to give you one example, here I have the data set of some houses. I have columns like size of the house, lot size, number of bedrooms, number of bathrooms, and final column is price of house. In terms of machine learning problem statement, we call the last column as a dependent variable, and the remaining columns are called as independent variables. Fine. So why the name dependent variable is given as price of column? Because as you can see, price of the columns depends on all other features or all other columns. That is the reason it is called as dependent variable. And in the machine learning setup, we always try to predict the value of dependent variable. So what we will do, we have data of some houses, a configuration of some houses, and their corresponding price. So now we will feed this data to a machine learning model, right? And this model will learn the pattern. What kind of pattern it will learn? Okay, that if this is the house size, and this many number of bedrooms are there, then this is going to be the price of the house, right? So we have given enough number of samples to the machine learning model. As I have earlier mentioned that machine learning model is nothing but a mathematical model. So it will learn the pattern in the form of mathematical equation. How? Like this. It will come up with some values, let's say V1, V2, V3, V4. Okay. And on multiplying these values with these respective columns and further adding them will give you the price of the house. So finding out these values of V1, V2, etc. and adding them up, which will be equal to the price of house, is nothing but the pattern learning which is done by the model. This process is also called as training of the model. So we are training our model to understand the structure within the data. Understood? Now, once it has learned, now this is one hypothetical example which I'm covering. There are different machine learning models which uses different types of equations. Now, once this model has been trained or it has learned the pattern in the data, next time if I provide a data of new house to this model, what it will do that from its previous learning experience, it will multiply these values with these values of v1, v2, and so on. And finally, it will predict the price of the house. So this is how machine learning model works. Do you have any questions, any doubts as far as of machine learning and data science is concerned? Okay. Now let me quickly give you sorry. Let me quickly give you the examples of at the different types of machine learning. Followed by that, I will quickly discuss some of the business use cases of machine learning, and then we will jump to the linear regression part. So this is a tree structure which is showing different types of machine learning, starting with the supervised learnings. Another one is unsupervised, and the last one is the reinforcement learning. So what is regression? What is supervised learning? If you remember the previous example of machine learning model, where we have given the model independent variable and its corresponding dependent variable values, right? So we are supervising the model that, okay, for this set of value, this is going to be the output. Understood? So in this way, your model is learning, right? So here we are supervising it, hence the name supervised learning. And if you check the last slide, you can see that under supervised learning, I have further two categories, regression and classification. Now, what is this regression? If your model, machine learning model, is going to predict a numeric value, in that case, sorry, in that case, that problem falls under the category of regression. Okay, let me show you another example of supervised learning. Here I have data set of messages and their corresponding labels, right? So message can be spam messages or non-spam messages, right? So what is spam message? What do you mean by spam message? You might be receiving unwanted promotional marketing related messages, right? So that falls under the category of spam messages. And the genuine conversation with you are having with your friends or relatives, they are called as non-spam messages. Maybe you have seen that spam folder in Gmail, right? So if you click on it, you will find out that all the promotional messages are there. Fine. So you can feed this data to a machine learning model, and later on that model can predict if the incoming message is spam message or not, and accordingly uh, it will it will send it to the spam folder or the inbox folder. Now, since here we are predicting category, this is not a numeric value, right? It's a category that we are predicting, spam or non-spam. So this kind of problem statement falls under the category of classification. So we have classification and regression and supervised learning. Let's talk about the unsupervised learning. In this case, if you consider the previous example, you will not have your target column or independent feature, which was the price of the home, right? So in this case, there is no target column, and the model will have to understand feature within the data on its own and come up with the uh, predictions. So one such example is clustering, which is supervised, which is unsupervised thing. And how it works is that if you feed that this data to a supervised model, maybe it will come up with some categories of homes, which means if I have smaller homes, maybe flats, some other homes which are relatively big, maybe bungalow, and maybe even higher size of houses, it will create another category for them, maybe mansion houses, right? So in this way, you can see that the predictions will happen in case of unsupervised learning. The last category of machine learning is reinforcement learning. So in many factories, you might have seen some robotic arm, right? Which basically moves some parts from one place to another place, or maybe doing some welding, etc. Right? This type of robotic automation comes under the category of reinforcement learning. So that was all about the different types of machine learning. Now let me explain what is artificial intelligence, what is machine learning, deep learning, and data science. Because I have seen many people are using all these terms interchangeably. So first, I'm going to explain this with the help of Venn diagram. So first we have AI. AI will gives the ability a machine to think on its own and make decision, right? So if you have higher volume of manual work, repeated manual work, so maybe you can develop some AI system on the top of it, and it will perform the task within fraction of second, or in a very less time compared to the manual approach. It is estimated that this AI will reach the market value of about $400 billion by 2026, and about 10 millions jobs will be generated in this particular sector. That's why nowadays everyone is behind learning this AI, ML, and data science. The subset of artificial intelligence is called as machine learning. I have already discussed about it in detail. Then we have something called as deep learning, which is a set of machine learning. Now, what is this deep learning? Maybe you have used face recognition application to unlock the phone, right? Or maybe you have used Google Translator or Alexa, or Google's voice assistant, right? So all these are examples of or applications of deep learning. All cool AI stuff that you see around you today is basically application of deep learning. It uses something called as artificial neural network, which is inspired from the functioning of neural. Got it? Fine. Now here comes the details. You can see that all this AI stack is nothing without data science, because unless you don't pre-process the data, unless you clean the data, your models, because all these AI models you are going to all these AI models you are going to train on the top of data, right? And if the data is not correct, the accuracy of the models is not going to be quite accurate. So to improve the accuracy of the model of prediction, we need some data science techniques to the data. I hope now the picture is quite clear. And here I was telling you that the overlapping data set. Let me quickly tell this about the project life cycle. So I have mentioned here data science. So basically, it is applicable to machine learning projects, right? Because you can think of this. Just a moment. So first you have business understanding. As in the first example I have shown you that that there was a one business, right? Some raw material was purchased, and then we had and we were selling that product in the market, right? And the demand was fluctuating, and hence we were not able to maximize the our revenue, right? So that is called as business understanding. You have to understand the whole business process, the underlying data, and so on. Then only you will be able to formulate the problem statement, what kind of problem you want to solve, right? So in this phase, who is available? Maybe the project manager, data scientist, or you may have a business analyst involved here. Next is the data collection part. So maybe a DBA who will get the data from the databases, or if the data is stored in a cloud environment, in a distributed cloud environment using such as Hadoop, Spark, etc. In that case, data engineer is responsible for fetching of the data or data mining. Next is EDA, which is all about exploratory data analysis. Here, the data analyst or data scientist will be doing the data analysis part. Next part is the modeling, which is machine learning modeling. So you just don't develop one single model for one problem statement. You will develop multiple models, right? And then in the next step, you are going to evaluate those models. Okay. So you will evaluate those models, that which model is giving you the best performance. And once the that particular model is selected, you are going to deploy that model into appropriate platform. Now, what could be the platforms where you can deploy the model? For example, I have explained you the example of mobile app which unlocks your mobile just by recognizing your face. So that's a machine learning model deployed on your mobile phone, right? Or Gmail uses spam detection. So Gmail is a web application, right? Inside that you have machine learning model which detects if the message is spam or not. So that is web, where your where your machine learning model has been deployed. Next one is what is that one? Let's say IoT devices, right? So you might have heard of IoT devices. So as far as these last three things are concerned, so this will be handled by a machine learning engineer. Okay. Now in some company, they have the requirement that maybe majority of these things will be handled by a single person. So in that case, you should also have the knowledge of some data analysis. You should also know some knowledge of databases in order to fetch the data, right? So that is how it works. So here are some examples of businesses where uh, machine learning is used. Let's take the example of Uber, which forecast the demand in each of the block of your city, and accordingly they will suggest the driver to go into that particular block of the city. Hence, without any delay, you can see that whenever you try to book a cab, there is always a cab nearby your area, right? Recommendation system, if you search for any particular product in a e-commerce website, on a e-commerce website, so you will get a similar product related suggestions, right, recommendations. And you may, along with the main product that you are purchasing, you may also select some of these recommended products. So this helps these e-commerce applications to increase their revenue. It is also used in OTT platforms, be it Netflix or YouTube like services. Speech recognition, language translation. So these are some of the examples that I have already discussed. In healthcare also, you can predict the illness using machine learning. Image processing is one such area. Uh, there are tons of applications of image processing. I have just highlighted one of them, which is object detection. So maybe through a surveillance camera installed at a particular junction, you can get the live feed, you can count the number of vehicles, and accordingly you can do the traffic management, right, in congested area. Then social media, finance sector, all these companies are also using machine learning. In factories also, you can use machine learning to do predictive maintenance, which will save a lot of time and money also. And not only that, big enterprises are using this and social media are using the machine learning, but also pure sciences and social sciences research involves use of machine learning. So that was all about the machine learning. Now I'm gonna start with the data science. Sorry, linear regression. So meanwhile, if you have any questions, let's discuss the answers for them, and then I will move to the machine learning part, the linear regression part. Okay, fine. So I can see that there are no questions. So just take a break of 2 minutes. I will be back in 2 minutes. Okay. Okay, students, I am back, and let's try to understand the very first machine learning model, which is called as linear regression model. And again, as I always do, instead of going into the uh, theoretical aspect of it, let's try to understand it with the help of example. Okay. So let's say we all went to some shopping mall or supermarket to buy some apples. Let's say the cost of each apple is 10 rupees. Apart from that, we have also taken our vehicles with us. So the parking fee of the vehicle is, let's say, 20 rupees, right? So a person who purchases two apples, the total amount of apples would be 10 into 2, which is 20, plus his parking fee will be 20 rupees, and the total price comes up to be 40 rupees, and so on. So I have just created a table for different count of quantity of apples. Fine. Now let's represent this quantity with variable x, okay, and this price with y, right? So the apple price become 10x. Now can we represent the relationship between this x and y in the form of some mathematical equation? Yes. Sorry. So I can write equation like this: y is equals to 10, which is the unit price of apple, into x, which is the quantity of apples you are purchasing, plus 20, which is the price of the parking fee, right? Now if you observe it carefully, you will find that it is somewhat similar to the line of equation that you might have studied in your 11th or 12th level mathematics, right? So what I'm going to do in the next slide is that I'm going to plot all these data points. Whenever I'm saying data points, I'm referring to the rows in my given data table or data set, right? So I'm going to plot all these quantities and price and their corresponding prices on the 2D graph. So on the x-axis I have quantity, on the y-axis I have price of the apples. So if I plot them, it looks something like this, right? And now let's join all of these points by drawing a line. So here I have a line which joins all these data points, right? And obviously this line will have the equation y equals to 10x plus 20. When I'm saying that this is the equation of this line, it means that each and every point which lies on this line will satisfy this equation. For example, if I consider this particular point, right? Can you tell me what is the x coordinate and y coordinate of this data point? On the x-axis, we have its value 6. On the y-axis, its value is 80. So if I put these values in the given equation, right? So x value is 6, right? So I have written 10 into 6 plus 20, which comes out to be 80. So for x equals to 6, the value of y comes out to be 80 using this equation. And you can see that geometrically this is true, right? If I draw a perpendicular from this point to the y-axis, the value of y comes out to be 80. So I hope you have understood. I mean, maybe you have learned this thing earlier, right? But I'm just trying to refresh those concepts. So here, your this straight line that I have drawn is nothing but your linear regression machine learning model. So this model has learned the pattern that whenever uh, you enter the quantity of apples, and if you multiply it with the value of 20 and add multiply it with 10 and add 20, you will get the price. So that is nothing but your machine learning model, and this machine learning model is having the equation y equals to mx plus c, right? In this case our m is 10 and c is 20. If you are not able to recall what is this m and c, so in the next slide I'm going to give you a recap of what is this m and c. So here c is nothing but it is called as y-intercept. So it is the distance between the origin, as you can see in the bottom left corner, distance between the origin till the point at the y-axis where this line intercept that particular y-axis, right? So that distance is called as c, or intercept, y-intercept. Then what is m? M is called as the slope. So this slope will tell you about the how inclined that particular line is. Now, how to calculate this slope? For that, consider any two data points on the line, for example, these two, okay, and find out the vertical and horizontal distance between them. Okay, how this can be done? Well, here in this case, the vertical distance can be calculated as 80 minus 60, right? Because their corresponding y-axis values are 80 and 60. So actually, I have developed this PPT on Windows using MS Word, and now I'm presenting it inside a Linux system, right, in LibreOffice software. So because of the compatibility issues, you will see that some formatting is getting changed. So please bear with me. So it is dy equals to 80 minus 60, which comes out to be 20. So the value of dy is equals to 20. Fine. Then we will calculate horizontal distance. This will be 6 minus 4. Now I hope you are able to understand what is why 6 and 4, because the corresponding x value for these data points are 6 and 4. Fine. Now we have the values of dy and dx. What is dy? Dy is horizontal distance. Dx is dy is vertical distance, and dx is horizontal distance between given two data points. Now to calculate the slope of a line, which is denoted by, okay, I'm going to write this equation in the see whatever I'm writing on the right hand side. Dy is equal to, we have dx uh, dx comes out to be 6 minus 4, so that is 2, right? Now we calculate the sum of slope of the line, which is dy divided by dx. That comes out to be 20 divided by 2. So I guess I'm resharing my screen. How is how calculation of m is done. Okay, and from this, so once you have the value of dy and dx, c and m, now we can write the equation for our line. So the standard formula is y equals to m x plus c, right? So we have just calculated the m, right? What was the value of m? It was 10, right? X plus c is 20. So for this line, the equation is this. That was a quick recap of mathematics that you have seen. Now what we are going to do is that we are going to solve some real world problems using this linear regression. And for this, I'm considering this data set of years of experience and salaries and corresponding salaries of the employees working at a particular organization. Let's take the example of TCS, right? So maybe in a particular month of a year, they have done lots of hirings. Maybe they have hired 10,000 of people, right? And now the job of human resource manager is to decide the salary for all these employees, right? So so this is quite time consuming job, right? So what we can do here is that we this TCS is already having hundreds of thousands of employees working in their organization, so they know that what is the experience their employees having, and their corresponding salary. This data is already there with them, right? So they will feed this data to machine learning model. So we are going to build this model, which is nothing but a linear regression model. Okay. And once this training is done, once the model learns the pattern in the data, we will feed the new data to this model. Okay, ML model, and it will do the prediction. What kind of predictions it will do? It will predict the salary for that particular employee. So in this way, we can build some software, okay, which internally uses linear regression machine learning model for the prediction of salary. And in this way, you can see that we are providing AI-based solution to the HR manager. Got it? So maybe TCS earlier required to hire, let's say, 100 HR managers to accomplish this task, but maybe now they can do the same thing just with the help of maybe 10 or maybe 20 HR managers. So thereby they are saving a lot of money on the employee, as well as they are able to process this data in a faster manner, right? They can you know they can issue the offer letter to these people quickly, right? So you have to always understand that whenever we develop a machine learning model, whatever predictions we are doing, why we are doing it, how it can solve the business problem, that is the most important thing in the field of machine learning and data science. Many people just talk about the machine learning model theory and implementation part, but nobody talk about how it is useful to solve the real world problem, right? So you must first construct the problem statement, and then you should go for the coding and data collection and all that. Fine. So in this case, our independent variable is years of experience, and dependent variable is salary, on which we are going to make the predictions using linear regression. Now these are common notations used, that independent variable is denoted with X and other one is with Y. Fine. Okay, so what I'm going to do here is that I'm going to explain you now that how linear regression model works internally, because there is a lot of mathematics involved in it, right? And don't worry if you are not a math lover. uh, you know just try to understand the concept behind it, because using Python code, you are just by writing a single line of Python code, you are going to uh, accomplish a very complex mathematical operations in the background, right? But having the understanding of this mathematics will help you in long run, right? So what I have done, I have plotted years of experience and salary on my 2D graph. So it looks something like this. Now you can see that compared to our earlier example of apples, all these points are not lying in the single line, right? They are somewhat scattered here and there. But if you observe carefully, there is still a linear pattern within them, right? So this is something is there always, this kind of smaller indiscrepancies will be always there in the real life data, right? So it will not be always there in the straight line. Fine. But since it is following that linear trend, we can use a linear regression model. So you must first do such kind of data analysis, data visualization, and then decide which machine learning model can be applied here. So we have come to the conclusion that we can use the linear regression model. Now, when I'm saying that uh, we have to construct a linear regression model for the prediction of salary, it means that basically I want to construct a straight line which will have equation y equals to mx plus c. Now, what should be the value of m and c in order to construct this line? Now, we have already mentioned that machine learning models are nothing but mathematical models which learn the pattern in the data without any explicit programming. So it how this works without any explicit programming, how it will come up with the value of m and c that we are going to see now. Let's say initially it selects some random value of m and c, and for those random value of m and c, this is the line that we are getting. Got it? If I try to do predictions using this set of data, using this linear regression model, I can see that the predicted salary for person whose years of experience is 6, but you can see the corresponding predicted salary is about $38,000. But actually, from our given data set, we know that the corresponding salary for the same person in our data set is $94,000. So we can see that there is a huge error in the prediction, right? Approximately 60,000 or $58,000 is the error in the prediction. And we also have errors, other error values with respect to each of the data point. Now we calculate the total error. Let's say first error with respect to first data point is E1, then E2 up to En, and let's sum up them and put them in a capital E, which is the total error. Fine. Now, what your linear regression model or this line will do is that it will try to adjust its position in such a way that it will reduce this error E. That is the mode. Fine. Now, how we can adjust in which direction it should go in order to reduce the error? Obviously, upward direction, right? Not only it should tilt itself in the upward direction. If you look at the point at the left bottom corner, if you see, it should also move the line in the upward direction, right? So there we have the C, right? And to tilt it in this direction, we will have to change the value of M. So we will change the value of M and C in such a way that this error will get reduced, right? So in the next iteration, you can see that line is getting changed. Again, the error is calculated, still there is a quite high error. So again, the values of M and C are changed. So this process continues. And finally, you will reach a point where the error is minimum. Now you can see that if we move line in either direction, error will increase, it will not decrease. So this is the best fit line that we have achieved. Or in other words, I can say that we have trained our linear regression model for the given data of years of experience and their corresponding salary. So this is how machine linear regression machine learning model learns the pattern from your data. Do you have any questions related to this? If not, then I will start with the coding part. Oh, sorry. So what I'm going to do is, let me open the science. Okay, let me open the Jupyter notebook. So we have come half mark for today's session. So let's take a break of 5 minutes there, and later I will start with the coding part. Meanwhile, if you have any questions, you can put the message, ask me a question in the chat window, or you may unmute yourself and ask me the question. Just give me a moment. I will be back in 2 minutes. Welcome back, students. Okay, students, now I'm gonna write the code to solve that issue of salary prediction. So for this, I'm going to use this data set salary underscore data dot csv file. Now, what is this CSV? CSV is nothing but a comma separated values file. So as you can see here, I have the column years of experience, comma salary, followed by several values of years of experience, comma salary. Got it? So I will use this one, and now let me create a new Jupyter notebook over here. I will name it Regression or Data Info Academy. Okay. So I'm writing in a short form, but I suggest you not to use such forms, because when you will have maybe multiple notebook files, you will not be able to identify that what is this, what is the meaning of this short form, right? So sorry, it should be LR, not LE. Yeah. So the way step is to import the required libraries. In this case, I will need pandas, okay, as PD. So going ahead, as and when whatever libraries we will use, I will again come back to this particular cell and I will add that import statement. Okay, so let's start with the importing of pandas. So I'm going to create a df data frame equals to pd dot read csv, name of the file, which is salary underscore data. Also, you will have to mention the extension, right? Now let me type df dot read. So you can see that whatever the data that was there, we have put inside our given variable df dot shape. So we have got 30 rows and 2 columns. So you can see that this is relatively a very smaller data set. I mean, see, our aim is to learn how to do machine learning, right? So we are using a smaller data set at the moment, but once you have grasped the idea of linear regression, maybe you can start working on even bigger data set. So my next step will be, okay, what I can do is I will also import the matplotlib. Import matplotlib matplotlib dot py plot as plt. So this is the library which is used for data visualization. Different types of graphs can be drawn with the help of this one. So I'm gonna plt dot scatter df. So let's have the years of experience. Let me copy the name of this. Copy years of experience, comma, df salary. So you can see here we have we had a scatter plot for given data, and again from this analysis you can conclude that we can go for the linear regression, right? Okay, fine. So what to do first? Whenever you solve any machine learning problem, let me explain you what are the some specific steps you have to follow. So the first step is to read the data from its source, and in most of the cases you are going to store it in the data frame. Then do some data analysis, data visualization as we have done. Then create x, y variables. Now what is this x? X will consist of independent variables. In our case, our independent variable is it is years of experience, right? Y is dependent variable, which is salary, right? So in Python code, I'm going to create these two variables and I will initialize them with the respective values of experience and salary from my data frame. Once that is done, I'm going to build a model. I'm going to create the object of linear regression, build ML model. ML model. Next step is train your model. Train the MLM, that is machine learning model. And then last one is the prediction. Do prediction. Whatever model we have trained, on that model we will do some prediction, right? So, and finally find out the accuracy. There is one more step is, that is splitting of data into training and testing data. I will explain you what does this mean. Just give me a moment. So first I'm gonna initialize x equals to df years of experience. Okay. So in this case, this is your x, and if you check the shape of x, it is 30, right? So, and if I check the type of shape is type, it is of the type of series, right? Now, it is in the form of series. It means that it's a one-dimensional data. Always remember in machine learning, whenever you have to create this variable x, it has to be two-dimensional data. 1D is not allowed. I mean, if you train the model with this 1D data, there will be an error. Now, why it requires 2D data? Because in real life, you see, uh, it is not just the years of experience which will help you to compute the salary. You should also, there will be, let's interview score, right? Maybe test score. So there will be many other factors. And if you create a table of such data, it's a two-dimensional data, right? It's a 2D data. Hence, whatever the libraries that we are going to use to construct the machine learning model, they expect your X to be in the form of 2D, right? So to do so, I will have to do some manipulation here. So let me show you what are those manipulation. First of all, this is in form of series, and if I just a moment, if I type dot values here, dot values, so it becomes a numpy array. So we use numpy array or data frame values for the training of our models. Hence, I have converted this into numpy array by using this values property. Fine. Next step is, please observe it carefully. X equals to x dot reshape 30 by 1. So this is your X, right? And me X dot shape is 30 only. And if we check the number of dimension, X dot ending, it's a one dimensional. My motto is to convert it into two dimension, right? So I have applied this reshape operation, and because of this, what will happen? You can see that now I have data is same, okay? Only 30 values are there, but now instead of one single array, okay, I have an array, numpy array, that consists of 30 arrays, each of which contains only one data, which is years of experience. So it is 30 by 1 array, right? If you check the shape and number of dimensions, it has been changed. Got it? So this is how I hope you are able to understand this ending shape, reshape, shape, etc. Right? We have already learned about these functions in under NumPy topic. Fine. So our X is ready now. Let's also create the value of let's initialize variable Y equals to df. Then I have what do we have? That is salary, right? Salary. So as far as the prediction is concerned, we are going to predict only one value, right? So Y can be one dimension, right? So there won't be any issue. We don't have to convert it into two dimensions. So this is the done. Now next step is to split the data into train. Now why it is required? Let me explain you. Okay, see what, so we have created X and Y, right? Just a moment. These are the two columns. We have X is this and Y is salary. Fine. Now what happens if I use all of my samples for the training of machine learning model, right? Model will get trained, no doubt. But if I want to calculate the accuracy of model, I'm in no position to able to do so, right? So what we can do is that we will split our X into two chunks. First is X train, another one is X test. I'm just giving them name. Proceeding on similar lines, We will also split Y into Y train and Y test. For example, and this splitting will be done randomly. Okay, so here I have data of person whose years of experience is, okay, I will have to take a screenshot of this. Just a moment. Okay, so maybe there are people whose years of experience is like this, right? 5, 6, 7, 8, 9, and so on, right? So one randomly it will get splitted, right? So 7, 9, something like that, and maybe 2 will go here, 5 will go here, and so on. The person who's, let's for the sake of example, let's say the person whose years of experience was 1, corresponding salary was 10,000, 20,000, and so on, right? So we have one going into extend, right? This particular is goes to this one in the training data set. So this will also go into the training data set. What about 2? 2 is in the test data set. So this value of 20 will also go into the 20. So the point I want to make is that the selection of these values in training and test data set is randomly chosen. But for X and Y, I want to say that same, corresponding values are splitted in a similar manner, right? So whatever values are extend value, what years of experience selected for extend, their corresponding salary will be, they will go into the Y train, and same for the X test and Y test. So I hope you have got that what exactly is happening. We are splitting our given values of X and Y into training and test data set. Now, why this splitting is required? Well, once this splitting is done, now we are going to train this machine learning model on this X train and Y train. So we will provide this pair of value. Once the model is trained, we will pass our X, sorry, we will pass our X test to the train model. So X test will be passed to machine learning model which is trained, okay, and it will do some prediction. So those predictions X test. If I want to calculate the accuracy of a model, performance of a model, all I will have to do just now is to compare these two values, Y test and Y thread. Have you understood what we are going to do now? Why this splitting is required and how the overall machine learning model training and testing will be done? Now, let's write the code for the same. So I'm going to quickly write the code, and for this we require one library. It is called import. We will require one function. I mean, whatever splitting I have shown you, you can write a Python, your own customized Python code. But since there is already ready-made function available, I will go for it for that one. So import, what is that function? Import sklearn dot pre-processing. I guess yes. From now earlier we were importing package, whole package itself, right? For example, import pandas as PD. But now in this case, I just need one function, so no need to import the whole package. I've written from package name import one particular function, which is this train test bit, train test suite. Train test split. Just a minute. Think maybe the name is models. Yeah, sorry, my bad. The name of the package was different. Now let me copy piece of code from this documentation. Yeah. So you can see that I have called a function train test split. To this function, I'm passing x and y. And let's say there is third parameter which is called as test. It means that if you remember this splitting, okay, if you remember all this splitting, so how much that decision is governed by the third parameter, that is test size. So ideally, for the training data set, we keep the range of 70 to 80%. For that of test will be 30 to 20%. Now, in our case, I have selected test size equals to 20%. So automatically the remaining 80% data will go into the training data set. So XY test size equals to 0.2, which is 20%. There is fourth parameter random state equals to 42. I will explain this particular argument uh, in a while. And on the left hand side, you can see that I have got four variables. So this is our current value of x and y. And after splitting, we are getting four values, right? So we will need to create four different variables to store these values, which are splitted, right? So same thing is achieved here. So I'm initializing this variables here. So let me execute this. And if you want to cross verify, let me show you X train. So here is my X train. You can see that randomly all the values have been selected. If you want to check the shape of it, dot shape. So 80% of the data goes into the training data set. So you can see that out of 30, 80% is 24. So 24 values are there in the X train. Corresponding salaries of these people are in Y train. Right? So these are the salaries of people whose years of experience is mentioned in X train. So we will pass X train and Y train for the training of our model. Okay. So let's create a model. And to create model, I will require, we'll have import the library, import again from sklearn. Sklearn is a library which is used for creating machine learning models, or if you need some models, ML related pre-processing, if you want to do. So this library is linear model, I guess that is the name of the library. import linear regression. Okay, I guess it is just linear. Or my spelling, there is a type. Linear. Yeah, it's done. So if you could recall, just a moment. So these are the steps we had followed, right? So we have read the data, created XY variable, we have done splitting. Now we are at this particular point. We are going to build the model. Okay. So to build the model, all we have to do is just so whatever calculations, those complex calculations we have discussed, all they will be taken care of using just this single line of code. That's why I had mentioned that don't bother about the complexity of mathematics. You are supposed to remember are going. So we have trained our model. What is our next step? Let's go back to, yeah. Next step is do the prediction. Now we are supposed to do. If you remember, we have split our data into X test and X train, Y train, and Y test. So this is X test, which consists of years of experience, and the corresponding salary of people is stored in the Y test. Got it? So we already know this their salaries. But what we will do, we will for X test. To this function, we will pass X for this for these years of experience. And if you check, if you compare it with some of these original salaries, so you can for salaries of 1,12,063, it is 1,01,000, so it is somewhat closer, right? So for some of the things, you can see that it is quite close to the predicted and original values, right? Here we have 7 and all that, right? So these are predictions. Now, what I will do, I will save these values inside a variable called prediction. So whatever are the predicted values, they are inside this variable y. Now, there is a problem. Accuracy. We have one way is to take their difference one by one, right? So for that, we will have to write the code, right? But instead of that, what we can do is so have seen me importing several but it might be quite annoying for some of you, but let me tell you, this is a very simple thing, because now you just have to import the function and use it. You don't have to implement the low level details of that particular available to you. Again, from sklearn dot metrics import. There is something called as mean absolute error. I will explain you what is this mean absolute error. So we have X test, right? Then we have Y test, and just now we have done some prediction Y predict. So maybe the years of experience was 5. Exact salary was, let's say, 60,000. Predicted salary is 55,000. There are so many examples, right? And so on, right? Now, problem before is to calculate the accuracy, right? So how it can be done? As I have, there is something called as mean absolute error, and this mean absolute error is calculated as absolute value of Y test minus Y predicted. Okay. So the difference of these two is, let's say, 60,000 minus 55,000 is 5,000. In this case, 70 minus 72,000 is minus 2,000. But since we are taking the absolute value, it will come out to be 2,000, right? And so on. So let's say that we have done 5 predictions, right? So 5 values are there, right, in our test data set. Once you have calculated this difference, this is not MA, MA is this. Mean absolute error is nothing but summation over I is to 1 to n, okay, for all the data points. Y test I minus Y pred I, which means, and obviously we are taking the mean of it. So in other words, I can say, let's say if we proceed along calculation of this difference, let's say for another one, the difference was 1,000, 3,000, maybe 500. Okay. So for 5 predictions, we have these many differences. So this mean absolute error for our given model, right? Our model have done these predictions, right? Machine learning model have done all these predictions, right? Using this. So for it, we are calculating the error. So obviously, if the error value is high, accuracy is low. If the error, this MAE error value is low, it means that the accuracy is high. So how it can be calculated? This MAE, it will be 5,000 plus 2,000, 8 stands for 1,000, plus 1,000 plus 3,000 plus 500. Whole thing divided by 5, right? Whatever may be the value is your mean absolute error for given linear regression. Now, instead of doing all these calculations, we have a ready-made function available here, which is mean absolute error. And all you have to do is just pass y test first to this function, followed by y underscore rate. Okay, and it comes out to be 6,000. So on an average, our uh, error made by our model is $6,200 models, 6,200 models, $6,200. Now, this is, you can say that this is a quite big error, right? Now, how we can overcome this, how we can reduce this error? Well, when it comes to machine learning, and if you want to reduce the error, what you can do is, sorry, is point number one is collect more data. So in this case, it was a toy data set, right? So we just had 30 rows, right? So maybe having records of it give you lots of variety of data to your model, and maybe because of that your model learn some interesting feature in the data, and maybe it will be able to do uh, more accurate predictions, right? So that error value of 6,000, maybe it will reduce to maybe 1,000 or maybe 500, right? Something like that. Second option is that try to collect more and more features. For example, I had discussed, we had just taken into consideration years of experience, right? But when you decide the salary of a person, there are few more things which are available. As discussed, maybe test score, interview score, or number of programming languages. I mean, if he's going for the software engineering job, right? So maybe skills level, right? Maybe you can have one variable called skill level, and you can mark it in the range of 1 to 10, right? So maybe based on how many programming languages that person knows, or how much content that he or she is having on those programming languages and all that. So when you have such a big data, I'm not talking about the big another big data. I mean to say relatively larger data, right? And then again train your model. In that case, you will surely observe that your accuracy will increase. Well, that was all about the prediction of the model, right? But let me add few more quotes and let me tell you how this match is happening, how the model is able to do the prediction. Before that, if you have any doubts, any questions, please let me know. Model dot predict. So here is model dot predict. Okay, I'm passing the value of years of experience. See, it is predicting the salary for that one. So earlier we have done same thing, but instead of just passing one value, we had passed multiple values which in the form of X test, right? I had written X test, model dot predict X test, and since X test contains about 6 values, corresponding six values were predicted. Here I'm predicting salary for only one person. Now, how come this predict function come to know about this salary value? If you remember, linear regression is all about y equals to mx plus c. So when I said that I have developed this model, linear regression model using sklearn, It means that this model is obviously having the value of M and C, right? Yes, it does have. Let me show you model dot. It's called coefficient. So this is your M, y equals to mx plus 1, right? Then you have model dot intercept, which is nothing but your C. Got it? We have equation y equals to mx plus c, right? So we already have the value of m and c here. Let's put the values. So m is what? Model dot coefficient. Okay. M. What is x? X is what? X is our salary, which is 8.5 in this case. 8.5 plus c, that is model intercept. So you can see that we are getting the same value, which is predicted by this predict function. So this is how it is happening in the background. Students, do you have any further questions or any doubts? Please let me know. Now, since we are left with 10 minutes, so what I'm going to do I'm going to explain you another concept. Code is 90% code. I would say it is same, no difference. In fact, more than 90% of the code is same, right? As earlier, whatever we have done, whatever linear regression we have studied is basically a single variate linear regression. It's something called as multivariate or multiple linear regression. What does it mean? Earlier we have just, if you consider the range of x, y, there was only use of experience, right? Use of experience and salary. But as I had mentioned, there apart from this experience, there can be some more other factors. So in this case, we have multiple values in our x, right? Or in our independent columns, independent features. So such type of, in this scenario, we basically develop multi. So because of okay, fine. So what I have done here is that I have considered another data set, which is a real life data set. But there is a website called cardecco.com. So they had a data set. They have published. They have made public the data of about 10,000 used car. Right. So I have taken a subset of it. I have just connected the data related to Swift car. Okay, Maruti Swift. So here is my data. So you can see that I have selling price, kilometer driven, and carriage. So in this case, selling price is my dependent feature because it depends upon how much kilometer car has driven or how old is the car, right? So now we have two independent feature, not just one. Got it? So I'm gonna create a machine learning linear regression model for this one. I have done some additional what I can say data visualization here. No need to focus on it at the moment. Mm, just have a look at this scatter plot. So I have selling price on the y-axis, and here I have kilometers driven, right? So you can see that there is a linear trend as kilometers are increasing along x-axis. The value of selling price is decreasing, right? It is decreasing, right? Same is the case for here. We have selling price on the y-axis and age of the car in years, right? On the x-axis. So as the age is increasing, selling price is decreasing. Now, as far as linear regression model is concerned, it is all about linear trend. It is all about straight line. So straight line can be like this. Just a moment. It could be like this, or it may have a trend like this, downward trend. So both kind of trends are possible, right? So here is the proof that for such type of trend in the data, we can use linear regression. And in this case, as I had mentioned, we will be using multiple linear regression or multivariate linear regression. But doesn't matter, code is going to remain same. Only there will be change of just one line. I'm going to explain you. So here is my x. X equals to kilometers driven and car age. That is the only difference. And now since the data is in two-dimensional form, you can see that there are two rows and two columns and multiple rows. So it's a 2D data, right? So no need to do the reshaping and all that. So here is my data, about 130 cars data with two columns. Y equals to car selling price. That's it. The rest of the things are same as it is. I'm splitting the data here using train test rate. Okay. And then we will use, here I'm creating, just a moment. Here I'm, where is, yeah. Here I'm creating my linear regression model, training it using fit function, passing my train data set to it. Once the training is done, I'm gonna do the prediction by using my model on X test. It will do some prediction. I'm storing those predictions in a YPred. And once this is done, uh, where is that code? Yeah, here I'm printing the mean absolute value, mean absolute error for the prediction of my car. So you can see that all the five, 7 steps I had discussed earlier, same steps are there. Only the change was that earlier we had just one column, that is DF years of experience. Now we have multiple columns from our data frame to be selected. That's it. Okay, with this we come to the end of today's session on machine learning and linear regression. You can use the same code for your any of your project. Maybe going ahead, if you want to do some project, select any of the data set which is available. Okay, just try to visualize the scatter plot. Okay, uh, obviously if you have the multiple variables, multivariate, in that case from Seaborn library there is a function called as pair plot. Use that one, and that will give you the plots like this, which I have already shown you. Observe the pattern between your target column and your independent features, and based on that you can take the decision to use create your linear regression model. Create your model, train it with training data set, and once the training is done, do the prediction using linear regression model on the using test data set. And finally, calculate the accuracy using. There are multiple ways to calculate the accuracy. Since we have a limited time, I have only discussed mean absolute error. Otherwise, you may also study something called as mean squared error or root mean squared error. These are very simple terms. If you have understood this, it will take a minute to get the details of these two metrics. Okay, fine. So, sir, I have completed the today's session.
Okay. Thank you, sir. And dear participants, maybe now we can have another 5 to 10 minutes time. So then you feel free to ask if you have any queries with Dr. Neele. And also you can suggest your opinion because the next session is unsupervised learning. So how do you feel about this session for supervised learning? What is your comment? Whether the same way of the method of teaching we can go, or we can go a little bit slow, or what do you feel? All of you feel convenient for these type of methods? For the participants, please feel free to share your views and ask if you have any queries before start the next session. Dr. Neely, you already shared any quiz for today's session?
No, sir. I will share it in a while.
Okay.
Yeah. Actually, there was a less time because what I thought of is to give them step by step hands-on, so that they understand what is the meaning of each and every statement. So that took quite long. So I haven't done the quiz part, but I will share the links of quiz shortly.